Okay. All right, so in the previous one we saw that Galileo was interested in studying free fall acceleration, and he wanted to know if free fall acceleration was constant. Okay, was it constant? And so he set up these inclines at different angles, and he found that the position over t squared was the distance traveled over the time it takes to get to that distance was a constant for any angle. This was a constant, and so then he concluded that even for 90 degrees, if you're dropping it like that, your x over t squared is also constant. Okay, so let's look at now more current ways. So here's again a experiment at different angles, 15, 30, 60, and 90. 90 is obviously free fall. At 15 degrees, we measure the velocity as a function of time. So 15 degrees, you can see the velocity as a function of time is increasing, and you can see that it's constant. Okay, so at this inclined plane, assuming low friction, okay, that is an assumption. We haven't really mentioned that, but assuming there's zero friction, which is not really real, but a low friction cart, say tons of oil or ice or something like that, we can assume low friction, okay? And then you increase this angle, and again, if you plot the velocity as a function of time, you're going to get not a constant velocity, you're going to get a straight line with a constant slope. You do that for 60 degrees, also a constant slope. Then 90 degrees, this is what you get for 90 degrees. And what do you think the slope is for this line? This velocity time curve or graph, what is the slope of this 90 degree one? It should be 9.81. Okay? So another way of looking at this is looking at the acceleration as a function of your angle. You're right, your angle is changing, and you measure your acceleration, and you get this curve, and you end up with this function. Acceleration is a function of the angle, but it's g sine theta. So if theta is 90, then the sine theta is 1, and we have acceleration is g. Okay? All right, see you in the next one.